Alright guys, welcome. Today we're going to do the next couple of lessons are going to be a little bit odd in that we're going to be putting several different sections together. So today we're going to start talking a little bit about section 2-3, and then we're also going to begin by reviewing factoring by grouping. So this is where we're actually going to start today. Alright, so example 1. And it's just going to say factor. Now, if you remember, factoring is to break it down to its parts. When you factor by grouping, you're going to have 4 terms. So let's say I have x cubed plus 4x squared plus 3x plus 12. Okay? When you factor by grouping, you can either put things, you can try to do a trinomial, but typically we end up doing a binomial grouping and a binomial grouping. Now, a couple of things I want you to pay real close attention to. I caught that sign in the parenthesis. Okay? Alright, so here we go. What you do is in the first parenthesis, you say, what do these terms have in common? Okay? So what could you factor out? What's their GCF? And hopefully you see that this one has 3 x's, and this one has 4x squared. So he has 2 x's, so I can factor out an x squared. So if I have 3 x's, and I factor out 2 of them, I'm left with 1. And the same thing, I have 4x squared, and I take out x squared, I'm left with 4. Okay, so that's how that first parenthesis factors. Now let's look at the second parenthesis. So when I look here, I say, well, what do these have in common? What's their GCF? And hopefully you say that the only thing they have in common is a 3. Now remember, when you get in a pickle, 1 is a common factor to every term. So worst case scenario, you can always factor out a 1. But in this case, I'm going to factor out a 3. And I want you to always factor out the sign that is here. So I'm going to factor out actually a positive 3. So 3x, when you factor it out, it's like dividing. So 3x divided by 3 is x, and 12 divided by 3 is 4. Now here's where you get to the critical piece. Sorry, I needed to get a highlighter. The critical piece is that these 2 parentheses after you do your factoring have to match. If they don't, then you've done something incorrect. Alright, so now what I want you to do is you take the first term, so the things that are outside the parentheses go first, and the things that are in the parentheses go second. And this would be my answer so that it's factored. Alright, let's try one more. What if I gave you x cubed plus 5x squared minus 10x, minus 2x minus 10. Alright, so step 1, let's group. So again, I'm going to try a binomial and a binomial. Notice again that I caught this negative in that second parenthesis. Focus just on the first pair and tell me, what do they have in common? What is their GCF? So I'm hoping that you said x squared. And so x cubed divided by x squared gives me x. And 5x squared divided by x squared leaves me 5. And when I get to my second parentheses, what do they have as their GCF? They are each divisible by 2. So you're going to factor out a 2. But remember I told you to excuse me, always factor out that sign. So we're actually factoring out a negative 2. So if I do negative 2x divided by a negative 2, I get x. And a negative 10 divided by a negative 2 is positive 5. I can do my quick check and make sure that those are the same, and they are. So now I go ahead and take the numbers that are outside my parentheses, x squared minus 2, and then the numbers that are inside my parentheses, x plus 5. Alright, so that's factoring by grouping. It's going to be an essential skill in our next video. Alright, now I want to take you back to the parabolas that we were graphing yesterday, those quadratic equations, and I want you to consider this quadratic, 4x squared minus 16x plus 1,000. And I want you to first determine if it has a maximum or minimum. So think about how the parabola would open. Okay, so kind of as a side note, think about if a is greater than 0. So if the term in front of the x squared is greater than 0, your parabola opens up. And if a is less than 0, your parabola opens down. So a parabola that has an a greater than 0 has is this a minimum or a maximum? That's a minimum, and so this one would have a maximum, okay? So this is a minimum, and this is a maximum. Right, the curve hits a minimum point here, the curve hits a maximum point here. So looking at this equation, look at the first term. 4 is greater than 0, so this parabola has a minimum. Alright, second thing I want you to do is find the min or max and where it occurs. Okay, again, we're going to try to do this without graphing it, because if you try to graph this quadratic equation, this is a huge equation. You're going to have to really alter your screen on your calculator to be able to see it. So let's go back to our pictures for just a minute. We've already said it's a minimum. Do you agree that the minimum occurs at this point where it ceases to decrease and begins to increase? Do you remember what that is called? It's called the vertex. So I need to now find the vertex of this function. So since it is written in this form, I'm going to have to do negative b over 2a. So there's my skeleton formula, negative and the 2. I need my b and I need my a. So I look up here, remember that this is a, b, and if you needed it, that would be c. So b is negative 16, and a is 4. Alright, so let's clean it up. I get 16 over 8. Now, that 2 represents what? That represents the x-coordinate of my vertex. Alright, so I know my x-coordinate. My question is, it also wants to know where it occurs. So I know my minimum is at 2, but what is that minimum? So now, to find the other piece of this vertex, you're going to take 2 and plug it into the original curve. Alright, so I have 4 minus 16 plus 1,000. Alright, and I am inputting that 2. And then I'm going to work it out. So I get 16 minus 32 plus 1,000, which in the end gives me 984. Okay? So that would be the minimum and where it occurs. Alright, last thing I want you to do is to give me the domain and range. Alright, so C, state the domain and range. Alright, again, I'm going to try to do this without sketching it. So look back at your picture for a minute. I'm going to unzoom so you can see these. We've established that it looks something like this guy. So his domain of this parabola would be all real numbers. So from negative infinity to infinity. And his range would start right here at the vertex and go towards infinity. So this point is on what? It's on the y-axis, so your range is going to be from 984 to infinity. And I do want to correct one thing. I believe this should be a brace because the vertex is a point on the curve, so therefore that point should exist. Alright? Okay. The last thing I want to do with you is begin an introduction of section 2.3, which talks about end behaviors of graphs. So the first thing I want to talk to you is called a leading coefficient test. Alright, we're going to first begin by looking at odd functions and even functions. An odd function would be x, x cubed, x to the 5th, x to the 7th. And an even function would be x squared, x to the 4th, x to the 6th, x to the 8th. What's nice is that all your odd functions behave the same and all your evens behave the same. Whoops, sorry about that. So these behave the same. And these guys behave the same. Okay, so I want you to first look at an odd function. So I could pick any of the odd functions. I could pick x, I could pick x cubed, I could pick x to the 5th, x to the 7th, but the most basic is the function x, which is just a linear equation. So let's look at just the typical line y is equal to x. Just your basic standard line. We already know from the inverse functions that that line is the line that goes straight through the origin on that nice 1 by 1 diagonal. Now, what is it doing as it's going to the left? This graph is falling. So it falls left. And what is it doing as it goes to the right? As it goes to the right, it is rising. Now consider his counterpart. If I were to ask you to graph y is equal to negative x, it's the same line but with a negative slope. So it looks something like this. Again, focus on his end behaviors. As it goes to the left, this time my line is rising, and as I go to the right, my line is falling. So what you'll notice with an odd function is that their end behaviors are opposite. One rises, one falls. So let's take a quick look at even functions and see if you can come up with anything for them. Alright, so let's focus on the basic even function. So my simplest even function is y equals x squared. So that parabola is your basic I. Now again, look at your end behaviors. As you go to the left, the curve is going up, and as you go to the right, the curve is going up. So it rises left, and it rises right. Consider his other one when we change the lead coefficient to a negative. So again, this time you have a parabola, but he's reflected over the x-axis, so it looks something like this. So now what are your end behaviors? As you're going to the left, it is falling. So it falls left. And as you go to the right, it is also falling. So an even function has the exact same behaviors. Alright? Next thing I want to do is I want to talk about what is a polynomial function. Okay? So these are polynomial functions. Okay, that's a polynomial function. That's a polynomial function. Not a polynomial. That is not a polynomial. And this is not a polynomial. So, what can you determine? A polynomial function has to be a few things. It has to be smooth, and it has to be continuous. Okay? So they must be smooth and continuous. If you notice, this one fails because he's not smooth. He has all these jagged points. And this one fails because it starts here, it goes to here, and then it drops. So it is not a continuous function. I actually have to pick my pen up and move it. So this is not continuous. Alright, we're going to end with one last quick example. Use the leading coefficient test. I think this is example 2. Use the leading coefficient test to determine the end behaviors. Whoops, helps if you guys could see. Sorry, I wasn't paying a lick of attention to my screen. Alright, ready? Because I know we're hitting 20 minutes. I want to wrap it up. Even or odd function? Even. So I know that his end behaviors are identical. Look at that coefficient. Is he positive or negative? Positive. Look back in your notes. If you have an even function and it is positive, it rises left, rises right. So he will rise left, rise right. Okay? Let's look at the second one. My question is he even or is he odd? Look at your you look at your exponents and it has a cubed, so he is odd. Alright, let's look back in our notes at our odd functions. Our odd functions do the opposite. So I have a negative coefficient, so that looks like this line. So he rises left, falls right. And that's where we'll end for the night. I'll see you guys tomorrow. Have a good evening.